Okay, how to solve it. This interesting handout is by George Polya, okay, Poyla. And he wrote this back in like the 1940s. It's an old thing. And when you look at it, it's simple. Like a lot of the things that we do for us are so basic, right? A lot of the stuff that we're looking at, how to problem solve, well, you're just going to do it, okay? But we have to stop and think about, we've climbed this mountain. We've been able to do amazing things, and now we're looking back and think that was not hard, okay? Our students are in the moment and actually having to experience this and deal with it at that time. So keep that in mind as you look at this and think about where the students are. And so quickly we get to a point where we understand and we can do these things, and then problem solving is not really a big issue. But especially early on, and then coming back and realizing and breaking down the steps, okay? Because especially this, 4-step problem. Understanding the problem, devising a plan, carrying out the plan, and looking back. Okay? So much of mathematics has been focused on carrying out the plan. I mean, we teach all the ways to carry out the plan, all the procedures, all the calculations, all the formulas, all the to-dos of carrying out the plan, right? And I like how this especially, 2 lines. It's the smallest actual part. And even I would guess, not that I would, I'm not from the 1940s, but I would guess back then they were having similar issues about calculation and formula and those kinds of things were what was focused on rather than fully understanding the bigger picture, okay? And so starting and really thinking about understanding the problem. So often, this is where students are really struggling to understand what's going on and their part in all of this. And so understanding the problem, when you start to give that to them, that's where they're like, well, what am I supposed to do? And you start to ask them about understanding the problem. You start to have that conversation, and that's what leads into a lot more of, oh, well, then I understand now, I've got a plan, boom, I can carry out the problem. If we understand the problem in full, then the other things are much more naturally in place for us, okay? But that's where students really struggle. What is it even asking me? What am I supposed to do, okay? When we fully understand, we often get the plan and we carry it out, okay? And fully understanding the problem, when I do fully understand the problem, that's when a plan almost self-creates, okay? When I get handed something to do. Now, a lot of times devising this plan is smushed in with a unit, right? So I'm doing my division unit right now. That's what we've been doing. So the next problem is probably going to use the exact same plan. Find whatever 2 numbers and divide them, and that's how I'm going to get my answer, okay? And this is a worrying concern that we have because life contexts aren't grouped like that. Okay, you rarely have a day, today is division day and everything I'm going to do is division. It doesn't work like that. I have so many different situations I get put into that when I'm here and in this situation, these kinds of problems, then it's a multiplication situation. Here over here, then it's going to be a division situation. Over here, I've got to use power. Things like that happen far more often for us. So the plan is very contextual. It has very specific meaning based on our understanding of the problem, okay? And a lot of times when I fully understand the problem, it puts it right in the context and it gives me the plan very quickly and smoothly. We've talked a lot about what kind of a plan will you do, boom, okay? So, but you still get kids who are like, I don't know what to do, and that's where we give them the half-baked ideas about, well, you just look for these key words and that's going to tell you all your problems. Well, not everybody presents it in the same way that a math book does, thank heavens, because it doesn't work that way all the time, every single time, okay? And being able to take the time to really break it out. And see, sometimes I can only devise so much of a plan, I can't see the whole problem yet, but I can see in this little bit what I can do. And then that result carries me to the next step of the plan. And then working with that carries me to the next step of the plan. And so being able to get those kinds of things is really important for being able to get the whole plan and then carrying it out. Okay? And so sometimes you're going back and forth between the second. I don't know how I'm going to get to the end result, but I'll take the next step. Okay? And a lot of students struggle with that. Is if you're not telling me the entire plan, I'm not doing anything. I don't know where you're leading me. That's just iffy kind of stuff. Okay? And you understand there's kind of a reasoning for that, right? If somebody doesn't know the end result of where they're going, are you going to start with the first few steps with them? Possibly not. Okay? So being able to take that time and sometimes going back and forth. Okay, well, this is how far we got. What's the next thing? Because you may give a huge problem that students are going to be looking at over the course of multiple units, okay? And you're going to break it down and say, okay, here's our little part for today. Here's that little piece of plan that we do know and we're going to carry out. And that gets us here, okay? And then you've got to teach and build so that way you can take the next step and the next. Okay? Now the actual carrying out, a lot of times it's calculation kind of stuff. It's actually doing that, and that's where we need to know math facts and things like that, where we can pop it into our calculator. Okay? If I don't fully understand the problem, I may not even put it in my calculator correctly. Okay? And if I don't understand the problem, the answer, I'll take whatever the calculator gives me, even if it's totally wrong. When I fully understand the problem, I also understand the context of all the answers. Okay? So, fully understanding the problem, if I understand I'm multiplying by something bigger than 1, my number is going to get bigger. But if I'm multiplying by something between 0 and 1, my number is going to get smaller. Okay? And so understanding that much more of the problem is something that you as the teacher always is expected of you. Okay? As the student, they're still learning some of that aspect. And so then you can ask them, does that answer make sense? Okay? When they carry out their plan, and this is part of the looking back, when we say, does that answer make sense? Does that work? Is that something that we expected? When I fully understand the plan and I have a good idea about where I'm going, fully understand the problem and create a plan for being able to start to attack it, I have an idea of what the answer should look like too. Okay, so I should have something. I shouldn't be saying that men are 72 feet tall. Okay, the units in there is going to be really important. I could say somebody is 72 inches tall. That's about 6 feet. Now that makes sense. That works in the context of the problem. That's a logical, reasonable answer. And this looking back is a really important thing for checking your work, okay? So just putting back your answer into the problem, and does that work, okay? Also, then you say, how well did the plan work? Do I need to modify the plan as I move forward? What parts worked perfectly? What parts need the adjusting, okay? Because now, the second problem I do should be easier than the first if I do a little bit of this looking back, okay? And this is where we can take some time with the students and talk about it, okay? What did you learn? What was easy? What was hard? What could we do differently as we move forward? So these 4 steps, I mean, really, we do so much of it, and I've heard that every single problem-solving strategy setup is based off of George Polya's How to Solve It that you've got right here, okay? And I'd say largely, yeah. Sometimes they put in they break down steps a little bit more or give a little bit more detail about X, Y, Z, but this is one of the easiest things, and it's amazing, George Polya is hugely known for this, and it's like, it didn't just get created in 1940. It is the method, but he was the first one to really write it down and formalize it. And so being able to have this, and then whatever textbook you have, how it's going to show that out for you, okay? But keeping this in mind, because every single step is really important. Too much of what we do in math classes nowadays is focused on carrying out the plan, getting it done, okay? Being able, can I do this, okay? With some of the Common Core, it's trying to get more about understanding those problems and about devising plans, but more about understanding the problems. Okay, that's kind of where they do, because devising the plan works based on how you understand the problem. You know, what plan works for you and what skill level you're at. Even a little bit of looking back is starting to show up more in the standards. And so it's a nice shift that we're getting there. I think that far too often it gets shifted a little too much, and we're way off on, oh, hey, here's this crazy different plan. Okay? Well, if that works for some students, you as a teacher, you need to know it. Are you going to teach it to all of your students? Probably not. Okay? But being able to get all that balance is a big deal. So really take some time, reread this, and just kind of log it in the back of your mind that you're going to refer to it again and again, the how to solve it. And you do this with not just math, with a lot of things, okay? So be okay with this helping inform other aspects of your life and other things that you're going to do.